Okay, so we're back to our two-sample t-test. We've got a nice picture here. Now there's many assumptions for the two-sample t-test, of course. We have to have two categorical variables against the one dependent numerical variable. No significant outliers, and we've kind of tested those, and we can do a quick test for outliers, right? Show outliers. We do the 1.5 IQR, there's no outliers. Let's go back and show the dots. But now there's another assumption that says these data points here for each of the different categories have to be normally distributed. So let's go ahead and see if we can assume that these points are normally distributed, or that they come from a population that is normally distributed. So let's go and test each grade level separately. So we're going to go to values for the categories. We're going to exclude the 11s. We'll have a look at the 12s first, and we'll have to draw the right picture for it. And I already ticked on show the normal distributions, little tag here, right? Okay, the box plot here is not quite symmetrical, which would be a really good indication for this being a normal distribution. And then we're going to go and test to see, well, look, I mean, the bars don't seem to fit perfectly in this nice normal distribution. But remember, this is a sample from a big population, so we're trying to make an inference about the population. Does the population from which these come from, is it following normal distribution? So let's go ahead and run that test. And can you see there's a test for normality? Now the test for normality is, we've got two choices here. This automatically tells me that I have less than 20 samples, so I need to go and run the Shapiro-Wilk. This will be my default, and you can look up Shapiro-Wilk and the ins and outs of that, but we're going to use Data Classroom to give us the conclusion that is. Fantastic. So it says the data appear to be normally distributed. So in this case, the starting assumption is that the data is normally distributed, and if the p-value falls below the 5% threshold, 0.05, we reject the null, and then we say that the data is not normally distributed. So in this case, look, if the p-value is less than 0.05, we reject the null. And the null hypothesis in this case, a little bit unlike the other hypothesis tests we run, is that the null hypothesis here is that the normal distribution is a good model for this data. So let's go ahead and find the same conclusion for this was which one? Okay, this is grade 12. Let's go for grade 11. So back into values, click, click, and it's already set up nicely. Again, the box plot here is not quite symmetrical, but it's not far off symmetrical. So I'm expecting this data set also to tell us that it's normally distributed. It looks like we do have more than 20 data points for this data set, but I'm going to be consistent. Shapiro-Wilk, off we go, let's run the test. And again, p-value is not less than 5%, so the data is normally distributed. Final thing is you can adjust the bins, right? You can adjust the look of your bar chart, but really, why bother? You know, Data Classroom is so clever and intuitive. It chooses, you know, the most appropriate scaling to give yourself a nice spread of data bins there. So I usually just keep whatever Data Classroom gives me. So there you go. We can be really, really happy now if we go back to our values and put both 11 and 12 on and go back to our picture here. We can be really happy that when we run this test now, the two-sample t-test, and we get this particular conclusion that there is no evidence to suggest the means are different, we can be pretty happy that this is a valid result, because one of the key assumptions that makes the test valid is that these data points follow a normal distribution, and they do.